One more problem from homework related to probabilities in section 4.2. And this is the last question. This is a very popular question. It has to deal with rolling 2 fair dice. Whenever you are asked to answer a couple of questions related to this probability experiment, you want to make sure you have your table with all possible outcomes. You can make a table like this by hand, or you can just search for one. So here it is. The first question says, if you were able to list the sample space, and we did already, how many equally likely outcomes will be there? And the answer for that, you can clearly see we have 36 possible outcomes. Okay, now this is the instructor version, so I will quickly check by clicking here. That is correct. Now for the second question, find the probability of getting a sum of 8. A sum of 8, we simply have to look at numbers that add up to 8. Now, if you look at numbers that add up to 8, you can start only at 2, right? Because 1 plus 7 will be an 8, and 7 is not on any fair die with 6 spaces. So we start at 2, 2 plus 6, right? And let's see if I can use my pencil to kind of point out. 2 plus 6, this is 1, and then it's a 3 and a 5, then a 4 and a 4, 5 and a 3, and a 6 and a 2. We kind of follow a diagonal pattern. And if we count all of these options, you can clearly see that the answer is 5 out of all of these 36 outcomes. So I will clear the drawing and I'll come back here. As soon as I get my spotlight, I'll come back here and clear all drawings. And as I said, I counted 5 divided by 36. And this is not divisible by 36, so this is the fraction that we are left with. And yes, that is the correct answer. Now, to find the probability of getting a 4 on the first die. Okay, so what we're looking at right now, and again, I'll grab my pencil. I'm looking at a 4 on the first die. Well, I realize this column has a 4 on the first die. How many pairs do I have here? 6. 6 over 36. That will be 1 over 6. Makes sense? We simplify to 1 over 6. So I want to make sure I do this correct, so I will check the answer. And indeed, that is the correct answer. Okay. Now, next question is right here. Find the probability of getting a sum of 8 and a 4 on the first die. Now, this question points out this should be a multiplication rule because it's and. So you may ask yourself, are those things that's independent or not? However, because your information comes in a table like this, it will be probably a lot easier to simply look at these two events happening at the same time, because and means they are overlapping events. I'm looking at a sum of 8 and a 4 on the first die. So I will simply, again, try to identify the sum of 8. Here we have the sum of 8. I already have my column with 4 on the first die. Do we see anything in common? Yes, we see. Hopefully you do see the same thing that I see right here. This is the only pair that is on both, which means I have only 1 out of the total number of 36. Okay, so we don't really have to apply the rules because with tables, it's a lot easier just to look at the overlapping part. And that is what we should write down for the answer. Only 1 satisfies both requirements out of the total number of 36. Okay, And I check the answer. And yes, that was the correct answer. Now moving on, let's see, what is the probability of getting a sum of 8 or a 4 on the first die? I will clear my drawings because now this question has to deal with the word or. You all know that with the word or you will be thinking of mutually exclusive events and the addition rule. So the question is, are these events mutually exclusive? Well, because they have an outcome in common. They are not, okay? And that should tell you to apply the general rule for addition. General rule for addition, if you don't remember, tells you to add the probabilities of the first event, probability of the first event, plus the probability of the second event, and subtract the probability of both. We already have the probability of both right here. So for this problem, you will simply add the probability of getting a sum of 8, and we already have it here, which is 5. And pardon my writing with the mouse, it's very difficult to write down. I will try. 5 over 36, that was the first one. And then plus the second one, a 4 on the first die, is this answer, which is 1 over 6. However, I'll write it down 6 over 36 just because I need the same denominator. 6 over 36. And don't forget, we are using the general rule because these are not mutually exclusive. We've seen that they have something in common. So I will subtract that common part. So the answer for this one should be 11 minus 1, which is 10, right? 11 minus 1 is 10 on the top and 36 on the bottom. If we simplify this, we will come up with the answer, which is 5 over 18. So I'll grab my spotlight and I will enter the simplified form, 5 over 18. And let's just check if that is the correct answer. And yes, that is the correct answer. I will clear the drawings now. Okay, so this is basically how you do this type of problems. It seems that the more complicated one is the one with or here. Let's see, I will finish this. So find the probability of getting doubles. So doubles. I'll grab my pen. And I'm looking for doubles. Here we have doubles. So it seems that on this column, all of these are doubles. So how many doubles do we have? Well, we have 6 doubles. So 6 out of 36 will simplify to 1 over 6. No big deal here, right? Next, find the probability of getting both dies to be even numbers. In order to have even numbers, I need both to be even numbers, right? I will be looking only at even numbers to begin with. So I'm looking at this row, and at this row, right? So on each row that starts with an even number, I will have 1. Oops, let me grab my, and again, so this is one that has both even numbers. This is one that has both even numbers. And this is one that has both even numbers. Okay. Now I'm looking at 4. The row with 4. Oops, sorry, I missed. Okay, I missed this one. It should be 2 and 4. So again, this was here from the previous problem. And I want to show you why it's really important to make sure you keep in mind which one are overlapping. That will come up later, but probably the reason I get so many questions about this problem is because of that type of question. So here we have, how many even do we have? Well, you can count even on these rows, and you have 9. 9 divided by 36. And if you divide 9 by 36 and simplify, that is actually 1 divided by 4. Okay, so let's check the answer. It is 1 over 4. I forgot to check the previous answer, but that is indeed 1 over 6. And now I'm getting to the same type of question. Find the probability of getting doubles, and we already have doubles, right? And both dice to be even numbers. We already have these answers. However, because the table is given, we are looking for both. So where do I have both? That's the reason actually I did not clear my drawings. I need to see both, right? Because and means both, and that will actually be 3 of those, right? You clearly see this that satisfies both requirements, the overlapping part. So my answer will be 3 over 36. 3 over 36 simplifies to 1 over 12. Okay, and now I'll check the answer. The answer is indeed 1 over 12. And now I will apply again the rule, is the addition rule because of and it's based on all of these answers. As I explained before on the previous questions, you will add the probability of getting doubles, which is this number, plus the probability of both dice to be even, which is this number. And you have to subtract the probability of both, because these two events are not mutually exclusive. They share common outcomes. Now, I will change all of this to common denominator of 36. It will be a lot easier for me to do the work. So basically what I will do to answer this question, I will start with this one, probability of getting doubles, which is 6 out of 36. And I'm changing 1 over 6 to 6 out of 36 because I have to perform some addition and subtraction. I need a common denominator. So this is basically this number. This number, 1 over 4, it's actually 9 over 36. And keep in mind, we are applying the general rule for not mutually exclusive events. That's why we have to subtract this one, which is 3 out of 36, or 1 over 12. So this work is based on all of these numbers, applying the rule for addition, just because this word means addition. So if you do the work right here, you will get 6 plus 9, which is 15, 15 minus 3, which will be 12. 12 divided by 36. 12 divided by 36 simplifies to 1 over 3. And that should be the answer for my final question. Let's see. It is 1 over 3. Okay. Now I will clear all the drawings and I will check the answer. Okay. And I hope this helps and you guys are learning from this. Okay. If you have any questions, any other questions, let me know. Thank you.